Hello everyone, welcome back to our channel. In this video, we'll be talking about law of exponents or indices. So exponents and indices just means power, okay? So for example, if you have something like x to the power 5, this 5 is sometimes referred to as exponents, sometimes it's referred to as indices or index, and sometimes it's simply referred to as power, right? So the power of x is 5 in this case. I'll be referring to this number 5 as power instead of exponent or index in this video. Okay, so let's start. So first law is, let's say we have x to the power m times x to the power n. So if we have same base x and different powers m and n, and if we are multiplying these two things, what happens is the power gets added, okay? So we get m plus n. For example, if we had something like x to the power 2 times x to the power 3, then since the base is same, which is x, our power gets added. So we get x to the power 2 plus 3, which will be equal to x to the power 5. Okay, and that's our first law. Now our second law is, if you have something like x to the power m divided by x to the power n, then the power gets subtracted, okay? So we'll get x to the power m minus n. For example, if we had something like x to the power 5 divided by x to the power 3, then this is going to be equal to x to the power 5 minus 3 because it's divide, okay? So we subtract the power and we get x to the power 2 as our answer. And that's our second law. Now our third law is something like this. So if we have different bases like x to the power a and y to the power a, okay, so we have different bases which are in the product form, but if they have the same power, then we can write this as xy to the power a. For example, if we had something like x square dot y square, then we can write this as xy whole square. So here we had x square and y square, we can write that as xy whole square, okay? Our fourth law is also very similar. So if you have something like x to the power a divided by y to the power a, then we can write this as x divided by y whole power a, okay? So our example could be x to the power cube divided by y to the power cube is going to be x divided by y whole cube. Now let's look at our fifth law. So let's say if we have x to the power a, bracket close, and another power b here, then what happens is these two powers a and b get multiplied, okay? So we get x to the power ab. For example, if we had something like x to the power cube or a 3, bracket close, and we have another power 5 over here, then it's going to be x to the power 3 times 5, which is 15. Our sixth law is a pretty interesting one. So if there is something like x, y, or any number, and if we have a power 0 of that number, then it's always equal to 1, okay? So for example, if we had something like y to the power 0, it's going to be 1. Or if we had something like 1000 to the power 0, it's going to be 1. Or 5 to the power 0, this is also going to be 1. Anything having power 0 is always equal to 1, okay? And this is our sixth law. Now, for our seventh law, we have something like this. So if we have x to the power minus n or m, it could be anything, right? Then to remove that negative sign, we can write this as 1 divided by x to the power plus n, okay? So when we move the numerator to the denominator, the symbol of the power changes. For example, if we have something like x to the power minus 2, we can write this as 1 divided by x to the power plus 2. This also works in an opposite way. So for example, if we had something like 1 divided by x to the power minus 3, then we could write this as x to the power plus 3, okay? So when the denominator moves to the numerator, again, the symbol of the power changes and it becomes plus. Now we have only two more laws. Our eighth law involves root. Okay, so if you have something like x to the power m and it's the nth root, then when we remove that root, what happens is we have x to the power m, right? This particular number n goes to the denominator of this power, okay, and we get x to the power m divided by n. For example, if we had something like x to the power 5 and it's 3 over here, then when we remove this root, what we get is x to the power 5 divided by 3, okay? Similarly, if you have something like square root x to the power 5, then in this particular case, when there is nothing over here, right, it's actually 2. So we can write this as x to the power 5 divided by 2, okay? And that's our 8th law. Now we have our last law, which is usually not included in the law of indices, but I just thought it would be better to include it here, so I'm putting it here. So if you have something like x to the power a equals to x to the power b, okay? If the bases are same, then this implies that the powers are also equal. So we get a is equal to b. For example, if you had something like x to the power a is equal to x to the power 2, then this implies that a is equal to 2, okay? So a and 2 are equal. And that's it. That's our 9th law of indices. So in this way, these are the 9 laws of indices that you need to learn before solving problems related to indices or exponents. I hope you found this video helpful. If you liked it, please give us a thumbs up and subscribe to our channel for future maths videos. Thank you.